All right, 4.4 number 1. Here we go. 4.4, problem number 1. Okay, so in this problem, imagine, if you will, that you're trying to get up a 45-degree angle slope here. Here's the slope, so actually you don't need that. So it's a 45-degree angle slope. Now you might say, okay, that's not too steep, and you're probably right. But here you are, you're going up by pulling on a rope. I will make the rope blue. Why not? Now, you're probably thinking 45 degrees. Really? Do I even need a rope? Well, never mind whether you need the rope or not. That's the story, okay? You're going up a 45-degree angle. Now, gravity's pulling you down, right? Now, gravity's pulling you down. It's pulling you straight down. Can you see that okay? It's pulling you straight down, and if you recall, the force of gravity pulling you down is your weight, right? And your weight is your mass times the force of gravity, and that's your weight. Now, by the way, Earthlings, what is the force of gravity, Earthlings? If you don't remember, we'll come back to it. All right. Now, this vector's at an angle. And like other angled vectors, like we learned with last chapter, it could be separated into two components. So I'm going to make them a different color. One is the vector that's in the direction of the slope. The other one is in the direction that is perpendicular to the slope. Now, the force of gravity perpendicular to the slope is going to be counteracted by the normal force, Fn. So we don't need to worry about that part. Not for this problem. Your gravity's pulling you with this part. The normal force resists with the exactly equal amount. You pretty much take it out of the equation. The only thing that you're having to deal with is the part of gravity that's pulling you this way. So you need to pull yourself upward on this rope with exactly equal force. So you need exactly equal force to that. Okay? So what is that force? We're going to find out. Now, you might remember, we got this angle here. Now you can look at it two ways. In this case, I'm going to look at it this way. This is 45 degrees, which would make that the adjacent to the angle. So, here we go. Let's see. I'm trying to remember how I did this. So, the cosine of theta is equal to the adjacent over the opposite. So, what's our cosine? Cosine 45 degrees is equal to our adjacent. We don't know. We don't know what that is, but we do know what the opposite is. The opposite's this line, so that's going to be the mass times the force of gravity, and which a lot of your Earthlings remember will be 9.8 meters per second squared. So, keep going here. Now, you're going to be putting your mass in here. I would say, before you start calculating, I would multiply both sides by 9.8 m. 9.8 m. So, you get 9.8 times the mass, cosine 45 degrees is going to equal, because these guys cancel, the adjacent, which would be whatever the force is that you're trying to overcome by pulling on the rope. Now, 9.8, my mass comes in, as always, at 108.9 kilograms. Cosine 45 degrees is equal to adjacent. Now I multiply these together, I get 1067.22, worry about the rounding later, times the cosine 45, which I think is, I want to say it's 0.707. I'd have to check. And unfortunately, I'm using my calculator to film this right now. So you can find out what the cosine of 45 is. Anyway, I did actually plug it all into my calculator, and I found out that 754.6 newtons is equal to that adjacent force. We'll call it the adjacent force. That's the force that's going in that direction, which means I got to be pulling up with 754.6 newtons. Now, one thing to think about, where do you round? Remember, since we only have 2 sig figs for our gravity, we can't have anything more precise than 2 sig figs. So we're going to end up rounding this, and I'm going to get 750 newtons, and I'm applying the force. I'm forcing myself that way. I may be pulling, but I'm forcing myself that way. Yeah, it depends on how you look at it. But I'm going to say it's 750 newtons, 45 degrees above horizontal. That's a bad H, isn't it? Above horizontal. So that is the force I'm creating. This is the direction I'm creating the force. Now, a couple things about number sense. Unless you're bigger than me, it's going to take a lot less force. So if you end up doing this and you get a number that's bigger than 750 and you're not bigger than me, you've probably made a mistake. Now, I've also know that some of you out there are looking at this and like, hey, I don't need to do the whole thing. You figured out a shortcut, didn't you? Okay, you figured out a shortcut. I'm not bothered by this. I don't think of it as cheating. If you're clever enough to figure out the shortcut, terrific. Go with it. If you're clever enough to have noticed the shortcut, you're clever enough to have done it. So I'm not too worried about that. Anyway, there will be more questions coming up because we're not done with this by a long shot. Thank you very much. Have a nice day.